Welcome, good afternoon. And this session is deploying applications to Kubernetes using Helm. My name is Andrew Pruski. I am a field solutions architect at a company called Pure Storage. And before that, I was a SQL Server DBA for around 15 years. I'm a Microsoft Data Platform MVP. I was a certified Kubernetes administrator, but it's only valid for 3 years, and I'm getting married in 3 weeks, and I just don't have time to study for an exam. That's also why I'm disappearing off pretty much immediately after this session, because I was told if I don't get back to Dublin by tomorrow, I will be dead. My contact details on the slide there at dbafromthecold and dbafromthecold@gmail.com. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecold.com. Posted multiple articles about running mainly SQL Server and containers, Kubernetes, but there's a load of stuff. Basically anything I find interesting in technology goes on my blog. You're more than welcome to check that out. And then finally, my GitHub account. All the slides and the code for the demos that we'll be doing today are on my GitHub account. I will post a QR code and a link to that at the end, so you can grab all this stuff yourself, go and play around with it, see how it works. But on to the session. Today, we're going to be talking about Helm. So I'm going to give you an overview of what Helm is, why we use it, a little bit of history about it, and then we're going to get into the meat of it. So we're going to do things like deploying an application, fairly simple, upgrading an application, and then, as inevitably, when things do go wrong, we need to roll that application back. And then we're going to have a look at something called chart repositories, where we can build our own Kubernetes packages using Helm, and then publish them in, say, a semi-private public region so other people can access them. All the app demos I'll be doing today are based using SQL Server in Helm. I'm a SQL Server DBA for my sins. I'm going to be using SQL Server. One of the real advantages I found with SQL Server in Kubernetes and basically containers is, has anyone here worked with SQL Server? Yay, nay? Ever tried to roll a CU install of SQL Server back? What a pain that is. Kubernetes, containers, blow it away, spin up the old version. Nice and simple, love it. Okay, so on to what Helm is. Helm is a package manager for Kubernetes. Although we don't call them packages in Helm, we call them charts, keeping with like the nautical theme of Kubernetes. We define our applications in charts. Now, again, coming back to the SQL Server reference, this is going to happen a lot. If you're going to deploy SQL Server to Kubernetes, you need a deployment or a stateful set, a service, PVs, PVCs, stuff like that. It's quite a lot. That's a lot of YAML files to be deploying, and you're deploying them in order, making sure everything's okay, and then you've got SQL Server up and running. With Helm, we don't need to do that. We can bundle all our YAML files up in one easy to manage package, which we can then version and share very easily. So that is pretty much Helm in a nutshell. It basically makes our life easier for deploying complex applications to Kubernetes. A little bit of history about it. It was created in 2015 at a company called Deis. Version 1 did not get much uptake. It was then merged with Google's Deployment Manager, and in 2016, version 2 came out. Version 2 had two components, a client-side component and a server-side component. Client-side component, Helm. Server-side component, Tiller. Tiller had some issues, mainly around security in the Kubernetes cluster. It could do a little bit more than people wanted it to do. So when version 3 came out in 2019, they blew Tiller away completely, and now Helm is a client-side application only. It's open source. It's written in Go. It's on GitHub. You can go check it out. More than 2 million downloads a month, and it has graduated status of the Cloud Native Computing Foundation as of April 2020. So it's been around a while. It's used quite a lot. Graduated status. So it's recognized. Anyway, one of the real cool features with Helm, it's like Docker Hub. It's called it was the Helm Hub. It's now the Artifact Hub. This is basically the Docker Hub for Helm. You can go and search for charts that you can install into your Kubernetes cluster. Now, a word of warning. Don't go and just find any random chart. They are verified, but don't go and just deploy whatever you find on here into your production cluster. You will more than likely end up mining crypto. go and verify your packages, pull them down. You can pull the packages to pieces, inspect them completely, and then have a look at them. Typically, though, I would use this as a guide for what is out there. When you're going into a production environment, even a staging environment, you're going to be building your own packages. And that's what we're going to have a look at shortly. Speaking of which, enough of me talking in the slides, let's have a look at the demos. So, I'm here on my local machine, and I'm a SQL Server Windows guy, although WSL is really cool, so I'm in that. Using Docker Desktop, and then the Kubernetes component of that. So I've got a one node cluster just running on my local machine here. One thing that's taught me about speaking at conferences, never, ever, ever trust the conference Wi-Fi. Which I'm going to break when we look at doing chart repositories later, so fingers crossed. So here I have a whole bunch, let's get rid of that archive folder, a whole bunch of, where are they, charts. I have a SQL Server chart, and in here, I've really simple, just a deployment, the SQL Server, and a service. That's all they are. Really simple packages. So what we're going to do is just deploy our application, and then we'll deploy a service so we can connect into it. Keeping it nice and simple. Okay, so let's navigate to a work directory. I'm going to create a couple. Oh, yeah, there we go. Am I in the right place? Yes, all good. We're connected. Now, Helm needs repositories locally with a reference to the remote location before you can install anything. If you go in the Artifact Hub, it will give you the exact way of adding that repository to your local install. One thing I should mention as well, completely client-side, the way Helm points to a Kubernetes cluster is basically off the kube config file. Whatever kube control is pointing at, Helm is pointing at. So, we're going to add a repository, and this is my this is the GitHub repository for this session, so I'm using this big long URL. Going to add that in, Helm repo add, giving the repo a name, DBA from the cold, and then URL. And now if I list, I have my repo there. So what I can do now is search for repos. With help, I was using the right version of my script. There we go. So I'm going to say Helm, search my repo, DBA from the cold, for something called SQL Server. And there we go. We get a name, a chart version, the app version, and that's 16.4 is SQL Server 2022 CU5. And then we've got a description as well. The search will always give you the latest version of the charts. If you want to see all the versions in the repo for all the charts, use the -- version flag. There we go. We have two versions. We have chart version 1, chart version 2, its app version, and the description. So that's CU4 2022 and CU5. Okay, so we've got a repo. We've searched for our chart. We can now go and have a look at installing. We can have a look. We can pull out some information about our chart. Just give it some metadata, an API version, app version, the description, a name, type, version, all that cool jazz. If we want to then run this deployment, best not to just deploy whatever we find in some random repo. We can do a test run. We can do dry run and then -- debug. Hit execute, and this will give us absolutely everything that is happening in that chart. So we've got some metadata at the top, and then we've got our manifest files. We've got our service, port, target port 1433, the default port SQL Server listens on. Type of load balancer. We're going to access this externally from the cluster. Yeah. And then we have our deployment. And this is a really standard SQL Server deployment. There's security group context, because SQL doesn't run as root within a container, so we have to add that in. The image itself, and then a couple of environment variables. I've spoken with Microsoft about this. It drives me bonkers. But every time you run SQL Server in a container or in Kubernetes, you have to accept the end user license agreement. It's a legal thing, apparently. And then we have to set an SA password. That is what you get when you're lawyers. Talk to people instead of engineers. Anyway, okay, we've done a dry run. Let's actually hit and install. So nice and simple, Helm install. When we install into a cluster, it is then called a release. So we're going to give this release a name. We're going to call it, and I'm great at naming things, we're going to call this SQL Server. Helm install, a release called SQL Server, DBA from the code, SQL Server. Nice, and we get some metadata about it, and we get some notes at the end there that typically are how to use and connect and things like that. But this is a demo chart for my deploying application to SQL Server. So deploying an application to Kubernetes using Helm session. Okay, so we've deployed Helm list. We can have a look at all our deployments, default namespace, updated, status deployed, chart, and the app version. All looking good. We can also use Helm status of the release. And that typically just gives us the exact same thing we saw when we deployed. So it's the same thing, just in a different form. And then if we jump in and we use like kube control, we can have a look at all our objects. We've got our pod, one pod, service, load balancer. The external IP is localhost because that's what you get if you deploy a load balance service to Docker Desktop, Kubernetes. Got our deployment, and then the replica set underneath that deployment. We are all good. Everything's up and running. We're looking pretty good. So instead of having to, you can get really complex with SQL Server in it. You can do a secret, deployment, service, PVC, PVs, all that stuff. Instead of having to run through that and having to worry about mismanaged versions, I've just got one nice simple package that I can just chuck into my Kubernetes cluster and boom, we're up and running. If I grab the image, yep, 2022 CU5, and then let's connect in to this horrible line of code that I can 100% type from memory, and then drop in to, say, just a tool to connect it to SQL Server, the MS SQL CLI. And then there we go. Microsoft SQL Server 2022 CU5. We want to look at our release history, Helm history, SQL Server. One of the real nice things I find about Helm is this nice simple commands. I want to find out the history. I want to find out the status. I want to install. It's just that one line. There's not these long things. It's just Helm, give me that. And then finally, if you want to uninstall, again, nice and simple. If I want to keep the history, keep history. Get rid of it. We can now see we're uninstalled. Helm list is gone. If we want to confirm that, we can use the all flag. And then all our Kubernetes objects. Gone. Uninstalled complete. Nice, simple. Spun it up, had a look at it, connected into it, didn't like it anymore, got rid of it. And then if I finally want to get rid of the history as well, nice and simple, Helm delete my release name. Gone. Okay. Oh, there's confirm. Excellent stuff. Okay. So, we've deployed in. We've got Helm search our repo for something called SQL Server. And that will give us the latest version. If you use the -- version flag, we get both versions of the chart. So it'll give you all the versions of the chart. In this case, we have 2. So let's try and install a specific version of that chart. Now, we use the -- version flag, but notice we use the chart version, not the application version. And if we check it out, yep, we've got CU4, which I know is the version of SQL Server in that version of the chart. So let's go ahead and install. Using the -- version, get rid of the debug and dry run. Everything's looking good. Helm list. Helm status. Oh no, we'll look at the Kubernetes objects instead. There we go. Right. Pod, service, deployment, replica set. All looking good. Got our service, localhost, confirming the, yep, CU4. And then let's connect in and there we go. Okay. So we've installed SQL Server 2022 CU4 to our Kubernetes cluster. Now, Microsoft changed the release cadence for SQL Server a couple of years ago now. They used to do service packs and CUs. They don't do service packs anymore. It's basically monthly CUs. So if you want to stay on the latest and greatest of SQL Server, you're going to be upgrading every month. I would love to meet someone who actually does that. I've never met anyone who does that. Mainly because there are issues with CUs with SQL Server. I remember one in for SQL Server 2014 that broke the SQL Server agent, which is the job scheduler. So people tend to stay a few CUs back. But anyway, we've got CU4 running. No, let's try that again, Andrew. We've got our release. I'm not going to lose status. Let's upgrade. Again, nice and simple. Helm upgrade our release name with our repo and the chart version we want to upgrade to. Boom. We got the same information we did when we deployed, but we also get a happy little message at the top there saying happy helming. It makes us feel nice, warm, and fuzzy that everything has gone well. We've got our release. We can see now we've got a revision of 2, status deployed, our chart, and our app version upgraded. Our status, pretty much the same thing, just different format. And there we go. In our history, we can see revision 1 is now superseded. We're status deployed on revision 2. If you have a look at the Kubernetes objects, we can see we've got our pod up and running for 43 seconds. Service again, actually let's just bring that up. And then we've got our 2 replica sets. The old replica set, holding the old image, the pod running the whole there. The pod running the old image, and then the status of 0, and we've got our new ones there. Confirm the image, and then finally, we'll connect in. And we're upgraded. Nice and simple. I started talking about SQL Server and containers back in 2017. Mainly because of this. Upgrading SQL Server on Windows can be a real kerfuffle. It's not too bad. You can script it out, you can shove it in, you copy the package up, there you go. But to be able to just go, boom, bang, bring it up in a very short period of time is very, very appealing to people like me. We've spent, I dread to think, you're looking after a server estate of 500 servers, spending time upgrading Patch Tuesdays. Very, very appealing to me. Even more appealing, though, is when things inevitably in the IT world go wrong. And we need to roll back something that we've just pushed out. So we've got CU5 running up, and say some unexpected thing has happened, and we need to roll back to CU4. Let's have a look at our release again. Okay, we've got a status of deployed, we're all good. And we've got our history, revision 1, revision 2. Cool. Got our Kubernetes objects with our replica sets down the bottom. And our replica set. So, there we go. Now, to roll back a release in Helm, again, really, really simple. Helm roll back our release to the revision number that we want to do. And we hit execute. And we get a nice, happy little message again saying rollback was a success. So Helm history SQL Server, we've now got 3. We've got 2 states of superseded. We can see we installed, we upgraded, and now we've rolled back to 1. But has everything gone all right? Let's have a look. Okay, we've got our pod age of 28 seconds, service fine, deployment there. And yes, we roll back. We are back on our old replica set. Nice and simple. Just to prove, there we are. We've rolled back. And just to confirm, we can pull out the container image and let's just connect into SQL itself. Yep. Back on CU4. Nice and simple. We installed, upgraded, let it run. Something was wrong. Not a problem. Helm, roll back, version 1, thank you, boom, we're now back on CU4. Okay. One thing I would recommend, and people don't talk about this with Helm enough, is we roll back using the old replica set there. If you go and delete that old replica set, say someone comes along to your Kubernetes cluster and is like, I'm going to do some tidying up, why not? And gets rid of that replica set, kube control won't be able to roll back because that replica set is no longer there. Helm will be able to roll that release back because Helm stores, I do, okay, yeah. Helm stores release information as secrets within Kubernetes. If you want to have a look at my blog, you can decode these secrets and get what the information is out of them. It's kind of an involved process using multiple decodes and truncates and things like that. But you can do it and you can pull out the information in there. Basically, in those secrets, decoded, base 64 encoded, are the manifest files that we deployed when we installed our release. You can go and check that out. It's in the notes of my GitHub repo. Just a quick blog saying this is how you go in, this is how you can inspect it and check it out. I did put it in here, but a bit of time. So. Cool. Okay, so let's jump back quickly into the slides. So I mentioned that, yeah, we can go ahead and just install charts from the Artifact Hub. But similar to like when you're working with Docker, you can pull down default container images. I'm doing it here with the Microsoft Container Registry, just pulling down the default images. But typically, we want to build our own stuff. We want to build our own images. We want to build our own packages. The reason I'm using CU5 2022 instead of CU6 or CU7. Is this being recorded? Anyway, Microsoft build their SQL Server images kind of weirdly. They copy all the files in via a zip file and then extract it out instead of like installing it like most normal people would. They, in the last two images, actually forgot to delete that .zip file. So the SQL Server container images were double the size what they usually are. So, and they're big anyway. They're usually about 1.5 gig, but these things were 2.3 gig. So one reason why don't rely on images from public repos, build your own stuff. Cool. Okay, so we're going to build our own chart. What we're going to do is we're going to say Helm create and a chart name. And that's going to build a directory structure for us. Do a chart name, and then we have a chart.yaml file. And in here we have some metadata about our chart. So some descriptions, app versions, chart versions, very generic stuff. Then we have a values.yaml file. Values.yaml file is where we can put some default values for our chart. So we could put like a default container image in there, some like default SA password for SQL Server. Probably a bad idea, but you can do it. This is where we put some default values. Then we have a charts folder where we can put charts that our chart depends on. You can build a stack of dependencies. I would recommend not doing that because you're increasing complexity, but yes, you can do it. And then finally, we have a templates folder. This is where we put our YAML files. Now, these are called templates, not manifests, because we can put code into our YAML files that when we deploy to Kubernetes, combine with either values supplied at runtime or our default YAML files, and that builds the full-blown manifest. So they're templates, not full-blown manifest files. You can put full-blown ones in there, but they're called templates anyway. Then we have a helpers.tpl file. This does exactly what you think it does. It's where we can put some code to help us build our manifest files. So we can put things in there, and we'll see in the demo in a second, where we can put code in to generate default labels for some of our Kubernetes objects. So when we install a package to Kubernetes, our templates get combined with anything in helpers.tpl, default values, or anything supplied by us, command line at runtime, and that builds our full-blown Kubernetes manifest files. And then the final thing there, notes.txt. Again, exactly what it says on the tin. This is where we can put some notes in on how to use our chart, how it operates, what ports to connect on, things like that. Okay, let's go ahead and let's build our chart. Yes, I've got 3 minutes. Right. Okay, let's build a chart. I'm going to say Helm create test chart. And that is going to go in off and build a load of stuff for us. We can view in the templates directory a whole bunch of stuff here. We got a horizontal pod adjustment, autoscaler, ingress service, blah, blah, blah. I'm going to get rid of all of that. And I'm going to get rid of the default values file as well. I'm going to copy some default templates into my chart. And this is what we saw beforehand. We got a deployment, a service, and a helpers.tpl file. I'll create a notes one as well. I'm going to get rid of the charts folder. This chart doesn't have any chart dependencies. You could leave the folder there if you want to, but I like to clean things up. So now we have a chart. Oh, yeah, too low, sorry. Chart and a templates folder. In the chart, this is what we get when you deploy, when you create. This is just the default stuff, whole bunch of stuff with its version and app version, kind of what you want to pay attention to down here. I want to show you this, and this is the this is the helpers.tpl file. This is where we can put code to help us build our manifest files. And this is a nice, simple one that just says define some labels. So we have a generator, Helm, usage demos, author DBA from the code. If we look at the deployment file, up here, under our metadata, we have template chart.labels. So by using this little bit of code, we can add in default labels from our help TPL file. Just helps us build up our manifest files to put information in instead of having to have repeat. You can call it out from your helpers.tpl. So let's go ahead, and I'm very conscious of time, install our chart. And what have I done wrong? Oh, ha 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 ha. No. Boom. Nicely done. Have a look at it. How long have I got? But if we have a look at our deployment on the author there, managed by author, generator, Helm. By using that little bit of code, helpers.tpl came in, got combined, and there's a whole bunch. That's a really simple example, but you can put some really cool stuff in there to help you build labels for your Kubernetes objects, and then a whole bunch of other stuff. But I'm not going to go into it now because I'm very, very conscious of time. I'm going to get rid of that chart. There are also a load of default stuff you can put in as well. One of the examples here is you could put release.name into your deployment file, and that's a default one that when you install Helm as a release, when you pick that name, it will also put that as your deployment name in your SQL, in your Kubernetes deployment. Another one is using something like values, and this references the default values file that you can put, say, a value in there, say, for container image, and that will take a default container image for your deployment, and you can push that into your Kubernetes deployment. Now, what I'm going to do very quickly is, where are we? Package my chart. I'm going to say Helm package test start destination, and now we have it. Here, TDZ file ready to go. Cool, I got rid of that. So, final thing, we have packaged our chart. And what I have here is a GitHub repo. Empty GitHub repo, ignore the Flux stuff. Flux is really cool. It's a function where you can push stuff to a GitHub repo and it'll grab it down off. You've seen it before. It will shove it into your Kubernetes. Kind of cool. But for intents and purposes, this is a blank repo. What I want to do is grab a URL, wherever it is. Oh, it's on the main branch. Yeah. No, I don't need code. I need the raw. I'm doing this wrong. My bad. I will grab that in a second. What I'm going to do is clone that repo down, jump into it, and I'm going to copy my package into that repo. I'm then going to index the repo, and that generates a index.yaml file, and all that is a metadata file that holds information about the charts in the repo. I will then push that up. Conference Wi-Fi. Nice. And now I can go to my GitHub repo. Click on index.yaml. Hit raw. And what I need is the URL, chop it off with the index.yaml. Grab that. Do that again. And add that as my repo URL here. Now, there are a whole bunch of programs out there that you can use for Helm repos. GitHub is just one example. The reason I'm using this GitHub is, give you one guess? It's free. Yeah. Okay. So, just to finalize, we have our repo there. I can list it. I can search. And I can install. So, now if I just confirm, we're done. So that was a very, very quick way of installing, upgrading, rolling back, building a chart, and pushing to a chart repository. If you have any questions, please come and talk to me. Here is the link to the GitHub repo. If you scan the QR code, it will take you there. Thank you very much.